Hello, my name's John Bland. I'm Managing Director of Tecsew, and unfortunately I cannot be with you today, but I'm going to try and give you a little bit of an insight into what we do as a company, the way we manufacture our goods, the way that we use 3D CAD in the design process, and perhaps what we do that's different from the traditional ways of manufacturing canvas work. We are based in Gosport, which is on the south coast of England, specifically the Solent area, which is the hub of sailing really in the UK. We supply many leading UK importers of quality brands such as Beneteau, Geno, Dufour, Hansa and Bavaria, to name a few. We're a husband and wife team. My wife runs the administrative side, mainly in the office, and here you see John Twine, who's our production manager. John is my right hand man and he's key to the business. He's our production manager and works on making sure that all timescales are met and things run smoothly, and deals with minor staff issues. But he's also out on site fitting and just dealing with customers as well. Here's a staff photo showing the team line up at the moment. We have plans to expand. We're hoping to move into a new purpose-built facility in September 2016. This will give us more floor space and will help us cope with the increased demand for our services. And the 3D CAD design process has been key to that. It's been well received. We've had great reviews in some magazine articles that have reviewed our product and design process. And word has started to get around now. We've been using the CAD now for about 5 to 6 years. With all our Sprayhoods, Cockpit enclosures, Biminis, anything that's complicated where design comes into it, being designed with the CAD process, because the customer gets to see before they buy. They get to have a look at the product, and we don't actually produce the product until it's signed off. So from the CAD model we can take various snapshots of the project from various angles, and we email those through to the customer. And we can then work with the customer in terms of feedback, and so sometimes it's changing angles and the overall structure of the project, but generally we try and get a good brief from the customer, and we will show them photos of similar projects to try and get an idea of what we're going to design. It's always best to design the project once if possible, rather than doing it 2 or 3 times, but we will do that if need be. And where the tinkering comes into it from the client's point of view is they can change window profiles, zip positions, but if need be, we may have a customer that's asked for a specific height, 6'4", to give them standing height on a project, and we may have advised this isn't going to look too great, it's not going to be in keeping with the lines of the boat, but the client has a chance to say, well, yes, I'm okay with that, or well, no, let's change it, let's bring the height down, let's bring this more in keeping with your normal way of doing things. So we'll still produce work which perhaps doesn't look as aesthetically pleasing on the boat always, but that's been designed to meet the client's brief, and they've been happy with that, they've signed that off. So small boat with a great big structure on it, customer wants vertical lines, you're going to struggle to get the best appearance on there. But generally speaking, most people want it to look right. And a big key part of our business is new boats. We supply lots and lots of importers of new boat brands. Unfortunately, many of the UK yacht builders that we used to supply are no longer in existence. Hopefully nothing to do with us, but brands such as Westerly, Moody, that you may even know over in the States, they're no longer with us. We used to supply these brands, and Southerly Yachts as well, or previously known as North Shore, we were suppliers to that company for over 25 years, but they failed last year. So it is mainly imported brands now. But with a new client or a boat builder, their client may not be local, and we can email to a client that's over in the States. So North Shore, for instance, had a few American clients, and we may have met them initially at the boatyard, but then the designs can be emailed backwards and forwards. So that side of it is great. generally with new boats, they want the product to look right. They want it to sell the boat. It needs to be practical, but they want it to sell the boat. So they love the fact that we can produce designs which they can A-OK before it goes into production. And if they have customers that that want to vary, then we can do that. So we've got a taller client, wants a little bit more height in the enclosure, we can do that. I'm going to stop here for a moment, and I'm going to run a promotional video that we put together for the company, which will give you a little bit of an insight into our facility and how we're doing things. Well, I hope you enjoyed that. Just gives a little bit of a brief insight into how we produce things and a little bit of a look around the factory. What you're seeing on the screen now is initially the wireframe that's developed to the model. It's not as complicated as it looks. Obviously experience comes into it. The rendered shots perhaps, or I've just posted one of the rendered shots of each project here, and then photo of the completed project. Not always possible to get exactly the same angle in the photographs as we've taken on the screenshot, just because of the elevation. So you're seeing here that there's no surprises really for the customer, and you can spend as much time rendering as you want in terms of producing the images, but what you're seeing now are some images that we've taken a bit more time in terms of producing, which we've used for promotional work. But these are all of projects which are actually completed and signed off and went into production. Our CAD design process has been reviewed by a few magazines, including the project you're seeing now, which was done for one of the leading UK yachting magazines, which was Yachting Monthly, and they actually awarded us the first 10 out of 10 that they've ever awarded a reviewed project or product. So we were very happy with that. They really were on board with the benefits of the CAD design process, and we were told that 2 other companies walked away from the project before we took it on. because of the difficulties in terms of putting something that was pleasing to the eye on the boat. You're seeing a shot here showing a Bimini. Bimini framework is sometimes difficult to work out, clearing the winches and such, but with a CAD we can do that. We can check winches are cleared. This is our CNC conveyorized cutting system. You would have seen a little bit of this in the preceding video. So this is Paul, who works mainly on the frame bending side, but here he's operating the cutting table. So you saw the conveyor working there. What will happen is the vacuum is released on the fabric while and the fabric's held down by clamps when the conveyor's moving. So that will drag the fabric to the correct position, and the vacuum will then be applied. If the vacuum was constant all the time, the conveyor wouldn't be able to move. So Paul's changing the pen here. Obviously different color fabrics will require a different colored pen, and we cut with this is Umbrella Plus. We cut with the fabric face side upwards, and we use Fisher Space pens which work on this fabric. So you're seeing a CNC cutting file on the monitor there, and that's been sent over to the table, and table's cutting. We can vary the speed. The table will actually cut quite quickly if we want it to, but generally there's no real need. And if it's cutting at full speed on a complicated project where all the panels are going to be different profiles, different shapes, then because of the operator time in terms of taking those panels off, there's no requirement for it to go super fast. However, if you were cutting many repeat products, perhaps halyard bags, identical winch covers, and you can have it feeding into a bin as they came off the conveyor, and sort of not attend it. The blade on here is vibratory. It's an oscillating blade. So before this we had a flatbed cutter, which different brands, and I'm guessing a few companies in the States have that sort of format. What the vibrating blade does is it requires less vacuum on the fabric. There's less drag with the blade, and you get less of what we call hanging threads. So basically where you don't get a clean cut, and some of the threads perhaps need going over with scissors just to make sure it's clear. Because it's conveyorized, the fabric needs to be fed onto the table exactly in line with the datum. The fabric feeder uses a laser to line the fabric up with the table, so the roller will move from left to right and it will present the fabric exactly on the datum point of the table. This is an MRP system, stands for Manufacturing and Resource Planning, that we use within the company, and here is a work order that will be generated for a framework to be produced. And I'm now going to show a small video showing how we manufacture our frameworks. Whilst the video is playing, I'll give a little bit of a rundown in terms of what's happening here. You'll see some text annotations on the slides, but I'll try and give an insight into what's happening. So basically we do not bend a framework until the CAD design is signed off. That's what we're doing that is different perhaps to the competition. With all the new work, we're actually designing the CAD model, and it's only when this is signed off that we go ahead and produce the frameworks. And some of what you're seeing on the screen here on this project, this was the one that was featured in the magazine. We gave a comparison in terms of what was on the boat beforehand and how the new canvas would look and address many of the problems that they had on the boat. You can see on the right hand monitor there on the screenshot that we can superimpose the model onto a 2D drawing of the boat if that is available. So the bar program is produced from that CAD model. We produce a DXF file and we bring it into a software package that we use in terms of generating a bending profile or a bending program to bend that shape, and we also store as a computer file a pattern of the bars. One, so they can be checked against it once they're bent, and two, the cut marks are on those drawings as well for the various cut points. So maybe the front tube will be smaller than the rear tube. The CNC program's fed through to this control system. It's not that complicated. There's a PC interface to do the programming, although it can be done manually on that keypad, but generally Paul is selecting the program on here, and once the program is selected, the bar will then be bent. So there's a device there that operates off a foot pedal, but basically the tube is fed through the 3 rollers on this machine, and the top roller will move down and depress the tube, and that roller is controlled by the computer program, moving up and down all the time. So a tighter radius will necessitate that roll depressing further into the tube. There are various size rollers that we can interchange on the machine for different size tubes, so different diameters will require different rollers. So most bars will be a combination of an identical radius in the shoulder corners, and then a different radius on the top. But we are not restricted to any specific radius. We, apart from the tightest radius the machine will bend, which is around about 160 millimeters, say 6 inches, 6-7 inches, which is more than enough for our needs. So we can draw on the computer screen whatever shape we like, whatever radius we want in the corners. If we've got a 24-inch radius and we think that a 28 would look better, a 30 that would look better, we can draw it, and we can just keep changing. And with the top profiles of the tube as well, we can match curvatures that we take from the coach roof or any other point. This is our frame shop, so the factory that we have at the moment is split, well, a combination of two different industrial units. The framework is primarily done in this unit here. So using the CNC cutting table, we would draw as a reference the correct profiles for these tubes, because we need to know where to cut the tube once it's come off the machine, and sometimes there can be a slight little bit of manual adjustment. What you become aware of once you start bending with machinery is that stainless is very reliant on its ambient temperature for consistent bending results. So when it's colder, it's much firmer, and it will tend to spring back a little bit once it's fed round a profile. When it's warmer, it will be much softer and easier to bend. When the tube's cold first thing in the morning on a winter's day, we'll probably find that it's a little bit underbent and maybe need to be manually adjusted. This device is, well, we imported this from the States. It's made by a company called Tri-Tool. It basically uses a power drill and a lathe cutting tool, and it cuts the tube. And one of the reasons we went over to this device was a manual cut-off saw created a lot of dirt, a lot of mess in the cutting shop. So this uses a lathe cutting tool, cuts the tube cleanly, quite quick and easy. The other option is obviously manual pipe cutters, but that's a quick and easy way of doing it. We rivet all our fittings on with stainless rivets. We never rely on the grub screws that come with the fittings. Stainless is too hard for a grub screw to lock and locate unless a little bit of a divot is drilled into the tube to take the grub screw. But we will rivet, and like I say, always stainless rivets. Anodized aren't strong enough for the job. We use a pneumatic riveter. We use the battery-powered version of the pneumatic riveter out on site. It's quick and easy, and it will store the ejected rivet post as well. So nice clean finish on the tube. So moving on, you can see the framework being put together. I'm sure we're all familiar with the fittings. We tend to not use screwed fittings unless there's no alternative. So all of our frames and deck fittings they are quick release versions. So even if the fitting comes with a screw, we would probably drill out the thread and use a quick release toggle pin. The heavier size frameworks, 32mm, 1.25 we use drop nose pins to actually attach the framework. Most of the screws that come with the fittings, we had warranty issues with them because it's quite a coarse thread. There's no lock nut on the back of that, and quite often with a Bimini framework with a lot of movement, sometimes those screws come loose without the customer realizing. We fit all our frameworks with these adjustable end plugs. You can wind each version in and out, and on the right hand side you see the standard fitting that can be wound out about 25mm, and if you need to extend the frame more, you can use the intermediate or the longer pin. You just interchange it. You screw one out, screw the other in. These are great for recovers. So if we're doing a recover sprayhood, sometimes we change those fittings because the framework may not be exactly symmetrical. Customer may have cut a failed fitting off the tube at some point, and we do a lot of production work, and certain boats may be slightly different as they come out of the mold. They just give a little bit of adjustment, and sometimes winding up the end plug by sort of 10-15mm can be all the difference between making sure the canvas work fits correctly. And canvas stretches. Later on it may shrink, but initially it tends to stretch. And what we tend to find is after 3 or 4 months, if you go and wind these end plugs out 10-15mm, guess half an inch, 3/4 of an inch, you can get that as new fit back into the canvas work. So continuing on here, yep, you can see Paul finalizing the framework. So this is a framework for a spray hood, and this was actually the framework that was used in the feature that we did with the magazine. So in the rear of the shop there, you can see we have a racking system for storing frameworks for production boats. But now so much of it is customized. Going back in the past, we'd probably run with up to 15-20 models of certain spray hoods on the shelf in the quieter months, ready for main season, and that would help us deal with the ebbs and flows of the trade. But we still have production models, but we find that we end up doing a lot more customization now, which is a little bit easier to do with a CAD system, because once we've digitized the boat and built up the data that we need, it's not that much more difficult then to go on and design a higher spray hood or something that comes back a little bit further. So it gives us flexibility. Right, we're going to move on in the video. I'm looking here now. Yeah, you can see how we store the frames. So we use a racking system basically without any boarding on it, and that works to keep them off the floor and stowed pretty well out the way. We fit a lot of grab bars. With some contracts they're put on as standard. They're normally welded, although we've developed a way of putting side grab handles on now that's shown on our website with standard fittings. But this is how we would normally attach a welded grab bar. So the pockets are all zipped, so that the canvas can be taken off fairly easily. And the grab bar obviously adds inherent strength into the framework as well. And again, this is a project that was featured in the magazine that gave us a 10 out of 10. This is the bending machine again in a little bit more detail. So this is a CNC control panel. The correct name for this machine is a CNC ring roller, and there are manual versions which are cheaper, and with the manual version that center wheel would be wound down to the correct coordinates manually, and you'd keep a record of the coordinates that you use for different radiuses. But with a CNC version, the computer program will drive that wheel. So basically, if you draw it, you can bend it. It's the center wheel that's moving up and down, and the two outer wheels that would drive the tube through. This is a cutting device in a bit more detail. Again, manufactured by Tri-Tool, an American company. It's a clean method of severing the tube. I'm sure most of you are aware of pneumatic and battery powered riveters. We use a battery powered version of that out on site, and this is just showing how we store frame fittings. So part numbers are shown there, and this is a frame shop. We also use this sometimes to lay out large templates, and we would use a ProLiner perhaps to register that template if it was something that was templated. Showing part of our zip storage. We buy direct from YKK so that we can get the colors that we want. We stock zips in many colors, so there would be beige, burgundy, red, green, a mid blue, probably a few more as well, but by buying direct we get the colors that we want. You're seeing some of the tools that we use for inserting and cutting the holes for lifter dot fasteners and turn buttons and eyelets there. Grommets are put in on an automatic machine which has a feeder, and just some shots around the facility here, but hopefully we're out of here in September and into our new building, which will give us more floor space and room to grow. I'm going to move on now onto a project, a 3D CAD project which we've worked on recently, and I've taken some screen recordings of the project. So let's see how we get on. What you're seeing here is the initial data that's brought in from the ProLiner. We use a ProLiner for a capture of data, unless the boat manufacturer can give us the actual relevant file. We prefer working on projects where there's no pre-existing canvas and the whole design is down to us, but this project had a pre-existing spray hood and cockpit enclosure, but the owners were looking to improve the cockpit enclosure. So mainly that they wanted more coverage with the roof section, so that basically the rear bar of the cockpit enclosure to come further aft, and yet to still have the framework work on a track and fold effectively against the arch. Now, you cannot capture all the data with a ProLiner in one location, so the ProLiner has to be moved perhaps 2 or 3 times, maybe on a large project 8 or 9 times. But what we do is we take reference points on each location of the ProLiner. So before it's moved, we capture 4 or 5 reference points, and then when the ProLiner is moved, we'll try and capture those reference points again, and like a jigsaw puzzle, we'll use those reference points to snap the data together. So the black here is the first file with the ProLiner in one location. The yellow is once the ProLiner has been moved, and what we're primarily doing here is getting points that are on the arch that couldn't be obtained with the ProLiner in the first position. And you can see the bar profile of the spray hood there. The yellow doesn't correspond with the black. The black is registered with a ProLiner inside the canvas, so it's the inside of the bar. The yellow is with the ProLiner moved to on the foredeck outside of the canvas, and so we've got the outside of the bar. So we spend quite a bit of time trying to fine tweak and get the best match lineup that we can, because there is a tolerance on the ProLiner, and points can be out by 1 or 2 mil, and you can also find that, you know, if it's windy, that will affect the accuracy as well, because it can put a little bit of a bow in the wire to the probe. So we would always take more than 3 reference points. We don't use the datum points that come with the ProLiner, because that's a set of 3 points. We would try and take at least 4 or 5, because you can guarantee once you've moved the ProLiner, one of those 3 points you cannot reach. So if you've got 4 or 5, you have a good chance of getting the 3 that you need to match the one part on top of the other. So here you are, we're just taking time, getting the best match that we can. Within Rhino, sometimes the lines can look quite far out, but when you actually go in and measure the discrepancies, it tends to make it look worse than it possibly is. So what can look like quite a large discrepancy, if you go in and measure it, is probably 1/8 of an inch, or 2 or 3 mil at most. So here you go. I've got a custom desktop as well. If you're using Rhino, which is our CAD package of choice, you can customize your desktop. You can bring the tools onto your desktop that you use frequently, and once you get to learn your processes of actually lining up the drawing and producing what you want, you'll know which tools you need. Rhino is quite a cheap package compared to SolidWorks. The reason we ended up using Rhino is when we first started using CAD, we looked at SolidWorks, and at that time SolidWorks wouldn't perform some of the functions that we needed. One that comes to mind is lofting to a point. So if you imagine a push-up pole on a flybridge tonneau cover, you couldn't produce those services. Those points have been addressed in SolidWorks now, but by the time they came back to us, we'd been using Rhino successfully for a couple of years, and to me, Rhino is the package of choice. It's easy to learn, it's cost effective, very easy to customize as well, and we wouldn't look at another package. To me, it does everything that we want. We don't use mPanel or any of the other plugins. We have a few scripts that we've written ourselves. And there's lots of add-ins that you can purchase, some of them free for Rhino, that will give you added functionality. So the main thing with Rhino is learning the relevant tools to do what you're to get what you need out of the package. That there are so many tools within the package that quite often, if I give advice to anybody that's trying to do something within the package, the tool is there. They're not aware of it. They're not aware of what can be done. And I have to wonder, even with ourselves, there's probably better ways of doing some of the bits and pieces that we do. But like I say, I would recommend Rhino, and the ProLiner is the device that we use. One thing with the ProLiner, I've been contacted by many companies asking for advice on how we do what we do, and there's a big learning curve, and to get on and do what we're doing with Rhino and CAD takes years and years of experience. But there's an easier way in. I would perhaps start using CAD for you could justify the cost of a ProLiner for basically copying in 2D canvas patterns. So if you've got access to a CAD cutting system, you could register those patterns that you have and stored away. They're much easier to find if they're on a computer, which with searchable database. So perhaps start with learning 2D skills. We started designing frameworks. There's nothing worse than having to cut frameworks and tweak frameworks on a boat. With a CAD, we can, if we want a framework to end up at a specific height in a specific location, you can draw that in CAD and you can work out the measurements that you want. And you can design the framework to work around winches and things. So I wouldn't look to go into the full functionality of the designing 3D canvas at first. I'd look to store patterns, basic products like dodgers, sail covers, design of frameworks, and then move on up as your skills build. What you're seeing here, you've probably seen this running in the background. The package is, you can see the spray hood is basically very similar to what was there before. We haven't really changed anything, but we'll try to improve the fit and get a better window line. But with the cockpit enclosure, we've brought the back edge of this is much more towards the vertical now. So we're giving the client more coverage, more volume in the cockpit enclosure, which means that he can get behind the wheel and pedestal easier. And if the back's rolled up and he's standing underneath it and using it as a bimini, the roof is further extended over his head. And the backstays are registered there because the backstays are the limiter in terms of how far back we can bring the canvas. This particular boat, the port and starboard are different. The winches are different. We see this on a lot of models because winches always operate the same way around. Sometimes the winches on the port side will be in a different location to where they are on the starboard side, and the winches deflect into the canvas on here. And also the arch, the arch isn't symmetrical, so it almost means designing the canvas work twice, and that's probably that's the same as if you're templating or measuring, because obviously if it is different, then you doing both sides. But generally most boats would be symmetrical, and we're aware of the things to look out for. Arches tend not to be symmetrical. Winches can quite often be different both sides. So you can put your various elements on different layers. You can turn layers on and off, which helps if you're working on particular aspects. So I definitely recommend getting used to using layers within Rhino, and you can change the color attributes of different layers. So if you select yellow for that layer, then anything you put on that layer will be yellow, and you can change parts that you've already drawn from one layer to another. What you're seeing here, I'm just selecting bits and pieces and just working on the profiles. You can unroll the panels when you've actually drawn the model, and it's easier to draw windows with a panel on the flat, so unrolled. And one of the reasons for doing that is you can put radiuses, you can fillet curves, offsets, all tend to work easier with the panel being unrolled. And once you've drawn what you want, you can roll that geometry that you've drawn back up onto the panel, and you'll see that in a minute. So I'm going to put a radius in the corner there, and I've selected that radius to be tangent to the two lines I've drawn. The old window line is on there as well, just as a reference, so I've turned that on and off, you can see there. But as I say, we're not changing too much on this, but with CAD, things like offsets, very quick and easy. It's a click of a button, and there you are. I've just rolled that back up onto the panel. So the curve that I've drawn, which is a window line I've rolled back up onto the surface, and then I've split the surface with that line, and then the part that's a window has been split from the canvas, and so I can give that a different attribute. And all I've done is put that on a layer that I have marked as window, and characteristics of the window layer is that it's transparent with a little bit of reflectivity, and the color that we deem that sort of matches window material. And we create a template for which you can do within Rhino. So when I open up a project, those layers are already there. So we have a canvas layer, we have a seam layer, a frames layer, we have a window layer, and then as you'll see here, when I split this panel, all I need to do is move it onto the window layer. So and once I've put it onto the window layer, it will automatically have the attributes of window material. Sometimes things don't work, but you tend to find out why they don't. So with experience, so if you can't split a panel by a line that you've drawn, what you probably need to do is just pull that line back onto the surface, and then it will split. So what you're seeing here is that's the window on the old canvas that's there already. I'm using that as a reference. I would have taken some notes if I wanted to change it. And we take lots and lots of photographs when we're on the boat as well. So if you're using the ProLiner, you cannot take enough photographs, and it helps to work with twin monitors, so you can actually look at a photograph of the boat whilst you're actually doing the design work. So I'd be aware and I'd take notes of anything that I wanted to change, but the client was quite happy with what was on here beforehand. So I'm filleting the corners of the window here. So you'll see what I'm drawing is a little bit different to what was there before, but mainly because there was a little bit of a mismatch in terms of the bottom profile of that side window compared to the spray hood window. And I can go in and take measurements. I can adjust afterwards if I think that perhaps doesn't look quite right. It's quite quick and easy to adjust. So what I'm doing here is I'm actually going to raise it up a touch more. I'm going to fill up those corners there. And you'll tend to have your standard radiuses that you'll use for a lot of projects. But as you can see, this doesn't take long, and it's quick and easy to adjust. If you were marking this out on canvas with chalk, pencil, it takes, I would say it takes more time. So now what I'm doing is I've rolled that profile that I've drawn back up onto the actual canvas, and what I'll be doing here is now splitting that canvas by the line that I've drawn. So I select the line, I split the canvas, I put that split section now onto the window layer, and it automatically generates, gives out the appearance of window. And now I've deleted the old window line, and as you can see, I'm just looking there. The side window runs into the profile of the side window in terms of the offset up from the bottom. It looks correct. It will be a different measurement up to what the front window is, but optically it looks correct. Now normally, most boats being symmetrical, you would just mirror this and it will work on the other side. But the other side of the boat is different. So what I've done, I've mirrored that line, which wouldn't have been on the service. Now I've used a command called pull to pull that onto the service. So basically it's just projecting it onto the service. Now I flatten that service with the that line. But what I'm going to do is I'm going to draw that now properly, because although I've just pulled that onto that service, the offsets may be different to the other side. So say the window was 4 inches up on this edge, it may not be, and you'll see that as I start to draw. So I'm taking some measurements just to have a look, and so there you can see straight away where it's different port to starboard, and that's because the arch is different. So I'm typing in the same offset measurements that I used on the other side. It's always a difficult one when a boat is different port and starboard. I always make the owner aware. I think we've all had from time to time where an owner will actually take out a tape measure and say, well, this is a little bit different port to starboard. So what we do is we try and get something that looks right, where the eye wouldn't naturally pick up that it's different. But obviously if somebody was taking a tape measure, they could measure the fact that this window is not the same length on the top edge as, you know, port to starboard. But the owner will be sent what we call CAD renders, photographs of the actual completed model, and we take photographs from all angles, and you'll be seeing some of those later. And we have the owner sign the project off. So I would make them aware that it's different port and starboard, and they would sign this off and say, yes, that's okay, or no, can we just change that a touch. So you're seeing the difference there between port and starboard, and that's because the arch isn't symmetrical, which will obviously affect the back cover as well. So now I'm splitting the service by that line, putting that section that's been split onto the window layer. Now it's got the appearance of the window, and I can delete the lines that I don't require. And so very quickly, this is starting to look now a lot like a completed spray hood on the boat. So, but I prefer to be designing the framework as well, and that way we have complete control over what we're doing. And we've redesigned a few of these before, where the client has paid for a new framework, and we've quite often put a second bar into the spray hood, just to give a little bit better support to the roof. So some of this is going to be relevant to people who are already struggling to use Rhino. When you create a service, it has a top face. Now you're seeing these arrows pointing in on one side and out on the other side. Basically, you need to be careful. So you can go into Rhino and you can change the direction. So that one's facing inwards, and I've just changed it so the top face is the outwards face. Now where that causes a problem is that if you unroll the port, a panel on the port side, and the CAD has got the inside service as the top service, then when you unroll it, it will be the opposite of the port side, if that makes sense. So basically, if you had a plastic template, it's like your template being the wrong way round. So you know, you're cutting out your Sunbrella Plus panel with your plastic template upside down, and so you're going to create the opposite panel. So I've just gone into here and I'm just made sure that every panel has the outward service as a top service, so that it's going to work correctly. So I'm just working on the model here. We need to obviously be putting the windows into the rear cover. The rear cover is very different now to what it was beforehand, but I have still got some points in there as references. What I've done there is I've averaged the zip position on the old cover between port and starboard. Now, because on the boat there's a fastening either side of the zip, and to use the existing fastenings, I need the zip to run down to the same location, so that there's a fastening just inside the where the zip is. And because the canvas distorts, that's not a straight line, as you can see, but what I've done is I've created a straight line from the old line, and I've turned the canvas layer off there quickly, so that just makes the canvas disappear. So just working a little bit more here on in terms of myself being happy with what I've got. I've drawn what's called a plane between those two lines, which is basically a service between those two lines, and what I'm going to do is project that service. You'll see this in a minute, it'll make sense. So that was created as what we call a poly service. I've projected that. Now what I can do is create a line where that intersects the canvas, and that will give me my zip line. So I shall be getting rid of that layer in a second. In fact, what I've done is I've put it onto a layer that I call planes, and then I've turned that layer off. So I have my zip line there now. Now that line you saw there is where a flat face, a plane, intersects the canvas. But what you'll find is if you were to lay those panels out, it's not actually a straight line. It will curve a little bit at the top, but aesthetically we find that sort of looks better. Now I'm not happy with how that worked, so what I'm doing, quite often we create a plane that matches the rake of the back panel, the angle of the back panel, and I'm going to use that to give me my zip line, which is going to be slightly different from what I've just drawn. But it's still coming down to the same position at the bottom, so it'll still catch the same fastening on the boat. So one of the things you can do with the CAD is you can reference angles that are already there, and you're seeing some of the planes that I've got here on that layer that I had turned off, which I've used for creating the back angle of the window and other little bits and pieces. So what I've done with that zip line now, if you were to look exactly side on, the zip is running up at exactly the same angle as the rake on the back door, which to me quite often looks best, and that's easy to do on the canvas, on the CAD. So you can see in the black there's a couple little reference marks from the window of the old cover, but that's all going to change because we've brought the canvas further back. The framework, like I say, has to fold against the arch still. So within the CAD, there was a track on the boat. We're going to replace the track. The slide track is going to be longer, but I've worked all that out in the CAD. The owner on this was quite specific, so you can see it's quite peaked on that center bar of the cockpit enclosure. He specifically wanted that height at that point. Now, left to my own devices, I would have liked to have created a better line across the top of this, but practicality comes in as well, and that height there gives the owner standing height at that point. So that's why it's peaked up in that position. And the owner's since signed this project off. So, but he would have had a chance to say, no, let's lower that bar a little bit. Let's reduce the height on that center point. But he's got what he specifically wanted on here, and that may not always be what you would perhaps design, but you advise the client, but the client is always going to be right at the end of the day. So you can advise the client, but at least they're seeing how this looks, and you don't get to the situation where you have a completed project and the owner comes back to you and says, well, that doesn't quite look right, and you turn around and say, well, we've done what you've asked for. But you know, the owner may turn around and say, well, you should have explained, or you should have insisted that perhaps I did something a little bit differently. Now, this is creating a CAD render. Basically, it's a photograph. It's a snapshot of the actual project, and we send these to the client via email. So, and we save these with a project. So we have these for future reference. We can load them up to our website, and in fact, we resell a lot of products that we create. The website works wonders for that because we photograph in detail, and we put quite a few photographs on the site, but we normally take a lot more in terms of enabling somebody to self-fit that project. And because we'll have a CAD file for cutting the canvas and a CAD file for bending the frameworks, it's fairly easy to replicate. Even if somebody came back 9 years later and said, I like that on your website, can you reproduce it? But what we find with the CAD shots as well is sometimes they show the client in more detail. Photographs, sometimes there's a lot of junk around the boat that stops the prospective client perhaps exactly seeing how the project works, how a framework might clear a winch. So we tend to take the CAD shots and put them on our website as well as the finished project. So I can spin this round to any angle if I'm trying to show the client anything in particular, and then I can take a photograph, or as I say, a CAD render. And you can change the settings, the background color of the render. You can change, I could go in now and change the color of the canvas just by going into that layer and changing the attributes of the canvas. If I wanted to spend more time and get a much more classier effect with the renders, you can actually superimpose or tile the canvas texture. So we've got photographs of all the Sunbrella Plus colors at high resolution, and you may have seen this on our website with certain projects. If we want to, you can tile or overlay that texture, so the exact color you're laying over the model, so you get the correct color with the actual weave of the fabric. If you were to go in close, obviously from a distance you don't see the weave of the fabric, but it can give a much higher or better look to the renders. And the same with window material, GRP. If you want to, rather than just classifying GRP as white, you can give it the reflectivity and the gloss that gel coat would have. And Rhino actually comes with a materials library, and there's a marine materials library in there. So stainless, Perspex, GRP, lots of the components that you'd find on a boat, that material is actually there, so you can actually assign that to a layer. And then if this was a motorboat with a glass screen, we can get very high class renders of that. And we use a plugin a plugin to Rhino, which is Flamingo. Rhino, there are various plugins for various extra functionality. What Flamingo will do is create much more classy or much classier renders. So they'll be much more accurate, and you can get the refraction off GRP, refraction off the window material. It takes more time, so we only do that for prestigious projects, or if we want some shots that we're using in a brochure. But there is, the possibility of doing that. You've seen some images on the screen, which are the actual CAD renders, the snapshots that are sent to the client. And we can show how the back door rolls up, the side door rolls up. This customer's having roll-up panels as opposed to zip removable. And here you're seeing the yellow line indicating the old profile of the framework, and the canvas line against the blue, which is the new line. And it's a handy tool for showing the customer, and much easier than sort of trying to set the framework up on the boat with the client there and holding it up and cutting bits and pieces off, and this is just much quicker and easier. We're now seeing on screen CAD renders taken with Flamingo, the snap-in package to Rhino, which will produce a much higher quality render. So we're seeing GRP looking correct, stainless steel with the correct refraction. You'll see a Perspex windscreen in a second, and there are all these are all generated with materials that are available within Rhino, so you can assign a layer, a material that's available within Rhino. So that might be stainless steel, and then anything you put on that layer will look like stainless steel. Equally with GRP, you can create a layer called GRP Deck Services. You can assign it the Rhino material, the GRP material. These are available in the Marine Materials folder, so there's various wood finishes, Perspex, window materials, and if you assign that to a layer, or equally just individually to a service, it will render correctly and much more accurately within Flamingo. So great for promotional shots, or where you just want to spend a bit more time generating a better render for the client. One thing worth mentioning, which you're going to see in the following shot in a second, is that Rhino can produce shadows, and you're seeing the shadows on this image from the stanchions. You can turn shadows off in Rhino, and you can turn off the reflection on a material as well. So either turn off shadows or turn off the ability of a material to show a shadow. So worth turning that off. We can see the framework folding, the sprayed framework is indicated on this drawing how that would fold. You can see it sort of just protruding through the front window of the sprayed. So we would have taken a shot in plan and showed the client how the framework would fold, and we could have turned the canvas layer off for that. It's worth noting that these projects you're seeing now, they're not generated with files supplied by the boat manufacturer. These are all drawn up with information taken with a ProLiner. The framework superimposing through the roof canvas there, we just do that to show the client's line of the framework. Obviously it sits inside the canvas within a pocket. But when we used to do that, the client often asked where the profile of the frame was. It's an easy way of indicating that. So we would normally draw up the services or the relevant services just to give us the ability to decide where we're going to mount the framework and design a project in scratch before taking a framework down to the boat. I'm now showing a couple of projects that were designed for a boat manufacturer that we supplied. So we're working with 3D CAD files supplied by the boat manufacturer here. Now we will use a ProLiner to verify that certain items are correct. So the windscreen that's manufactured on this boat may differentiate slightly, and sometimes winches and deck fittings will be slightly different to what's on the CAD file. But modern production techniques, the GRP services will be correct. We've digitized around various new boats where we've had the CAD files, and they don't vary. It's within millimeters. But you can see here we can reference heights. We can show how the main sheet will work in terms of clearing the framework with a Bimini. That one was on a slide track. It's a great tool to agree a design with a boat manufacturer. Lastly, what I'm showing here is that Rhino can also be used for upholstery. So again, great tool for working out the design, getting the profiles right, and showing the customer how this will work with fluted vinyl and without fluted vinyl. What should be remembered is that we're not just drawing pretty images here. The CAD model here will actually be used to generate the cutting program. We can take all of those services, we can flatten them out in the CAD, we can nest them so they're cut correctly within the material to save as much material as possible. Well, I hope you've enjoyed the presentation I've put forward. Obviously, I've only touched the beginnings of CAD design, and it probably opens up many questions. I'm sure you all have many questions in terms of how you would implement CAD into your business. You know, where you would see the gains, and I guess the most complicated part of all of this is it's no good generating a CAD model unless you have the means to then go and produce the canvas work. So if you have a CAD file, you need a way of actually cutting those panels out. So you need access to a CNC cutting table. But what I would suggest is over here in the UK, there are a number of, shall we say, suppliers into the marine industry now that have actually themselves installed a CAD cutting system. And they're offering this CAD cutting service to smaller companies. So it may be that if you can't justify the cost of a CNC cutting table, research, maybe there's a larger company that would offer this service to you. So maybe, shall we say, a competitor, but that wouldn't mind, you know, for a fee, offering this service. Or if it's not already being done, perhaps one or two of the suppliers into the marine trade out there, you know, what your fabric supplier may want to offer this service. And the advantage is perhaps that if you were cutting out a project and you needed, shall we say, I'll use feet and inches, but 24 foot 9 inches of a particular colour, because you've nested that project down into panels, they could actually cut all of the panels, reinforcing the whole project for you with no waste. Or, you know, if you deem that you want a couple of meters spare, then you could order that on top. But perhaps rather than ordering the required length of material, you purchase, and obviously there's a fee for the cutting service, but you would prepare the CAD CNC cutting file, provide that to them, and they would cut those panels out for you, and you would have nested those down, so you know exactly how much material is required. And perhaps that's the way forward to enable smaller companies to start on this journey with the CAD process. And obviously, if it works out, the company grows, then you can look to maybe purchase your own CNC CAD cutting system later on. But surely the main advantage, perhaps for us anyway, is the payback on it is more now than when we first started. Because if we go back, I would say probably the last 12 years now, near enough every product we've generated has been cut out with a CNC cutting file. And even for simple items which are templated manually or perhaps measured manually, so this might be dodgers, it could be a wheel and pedestal cover, we would digitize that pattern and it would still be cut out via the CNC table. Even if it was a one-off, it wouldn't be cut out manually. So that means that we now have that file which can be replicated. So if the client comes back to us in 12, 15 years time, we've got that file, and we're starting to get the payback now, because we're ending up with clients coming back to renew some of the canvas work that we did 10 and 12 years ago. And I mean, it's not unusual for products to last even longer than that, but we'll often have or we should have the file, and unless they're changing the design, you know, it's easy. We can just search our database. Key to this is making sure you save every file with the relevant information, but there's no having to re-template the job. And if windows or zips need to be moved, then that's minor. That can all be done. So yes, I hope you've enjoyed the presentation. I'm sure there'll be many more questions, but I would say start out with something like a ProLiner. That's what we're using. You could use that initially for, like I say, digitizing templates. So you have a digital file of that template that you created, and for more mundane work initially, and you could use a CAD package like Rhino, which you can download on a trial basis and use free initially, and you'll see how easy it is for sail coats, dodgers, more basic products at first. And with those you're working in 2D, and it's worthwhile learning these skills on a 2D basis first and becoming conversant with them before sort of expanding and looking to go down the 3D route. So that's when I've been contacted by other people interested in sort of trying to replicate what we've done. The problem is that you've got somebody with no CAD experience that's perhaps looking to go straight out there and within a couple of months be producing Sprayhoods, Cockpit enclosures and Biminis. That's not going to happen. And you start with something more basic that you're happy doing. Download the package, as I say, download Rhino. It's free initially, and perhaps have a go at drawing out dodgers, sail coats. Learn how to annotate, and for sign rating it's great, because you know, you can pick whichever Windows font that you want. If you haven't got the font, it can normally be supplied to you. You can scale the font. You can see exactly how it's going to look, and if you're cutting out with a CNC cutting table, that will actually mark the letters on the dodger for you, for example. In the UK, we call the side screen that laces between the guard wires and stanchions a dodger. Not what you term as Sprayhood, but you could play around with the package and find out if it's for you. Also, try bar design work, drawing out frameworks, and you would take some relevant points from the boat. So you would work out the height of the mounting point above the cockpit floor, for example, the height that you have available underneath the boom, the width that you require and the span, and you can start to draw that out and work out some of your frame geometry as well. So that they're good starting points. Okay, I hope you've enjoyed this, and we're hoping to possibly link up and maybe do a question and answer session. But that's going to be down to Steve. Hopefully that will be plausible.